on your review. Make sure that you are ready for that and everything. Did you all three of you do your review? Okay, so pull that out. Heidi, you got yours done? Okay, so pull that out and we'll go through those problems. Here's my pen. What did he say? Okay, so calculate the mass in grams. So we're going to start out with what we're given. We're given 2.58 grams of fluorine. We need to convert that. No, I'm sorry, we're given moles. I always do that. Every year I do that. I make that mistake every year going through this. Hello, sir.
Hi.
Yeah.
I was working on it last night. I think I let you know.
Okay. So when you get home tonight, go through it and make sure that go through the answer key that in the video.
Okay.
Make sure that you've got your answers right. Okay. So we want to get rid of moles of fluorine. So I'm going to put moles down here. I'm going to put grams of fluorine up here, and I get this value from the periodic table. All right. I'm going to multiply these two numbers, and then I divide by 1, but you can do that in your head, I'm sure. So we need 3 sig figs down here in our measured amount because that's what we started with up here was 3 sig figs. So you need to have 3 down here. So if you got 49, you need to make sure that you put the 0.0 to get to that 3 sig fig mark. Because remember, sig figs are back on this exam. You're going to end up getting graded on those. Ernesto, do you have your review done?
Yeah.
Okay, and then get that thing out of your ear. All right, next one. Write down what you're given, 285 grams AU. The test tomorrow is pretty much exactly like this. Like it is hard to tell the difference between the test and the test review. I have changed the amounts here and I've changed the elements or the compounds, whatever it is. But everything else is pretty much identical. Like it takes me a second to identify the difference between the test and the review. All right, I'm getting rid of grams of AU and I'm going into moles of AU. Okay, 1 mole here, I get this value from the periodic table. It's 197. And this time I'm going to multiply by 1 and then I'm going to divide by this value. So I end up with 1.45 and that's going to be grams. No, I'm sorry, moles. Geez, I'm having trouble today. Sorry, y'all. Moles of AU. And then I want you to box in your answers. Good morning.
Hi. Where's the quilt? I'm sorry to interrupt.
That's fine. It's in the athletic office.
Okay.
You'll see it when you first walk in there. It's on the cabinet where all the extra paper's kept. All right. So how many moles are there in this many atoms of barium? So again, we write down what we're given. I want to get rid of atoms of barium. And they want me to go into moles. Okay, 1 mole here. And then it really doesn't matter what we're dealing with because this conversion unit is exactly the same. 6.02 times 10 to the 23rd atoms. Now make sure on your calculator that you're doing this right, okay? When you type this into your calculator, use that EE option on your calculator so that this turns out the right way. Because if you do times 10 and then the caret to the 26, it works out on the top. But when you go to the bottom, if you don't put this in parentheses and you're trying that business, it's going to end up multiplying by this because of order of operations. That's why you got to put this in parentheses if you don't use the EE function. If you get an answer, I mean, think about what you're doing here. Okay, people will end up with an answer like 10 to the 46 or 48 or something like that. You're dividing 10 to the 26 by 10 to the 23rd. Okay, you should not end up with 10 to the 48 or 49 here. If you do, you messed something up on your calculator. Bring your calculator over to me. Let me show you how to work your I don't care if it's in the middle of the test. Let me help you with it, okay? Assuming you have this set up right, I will help you with your calculator, okay? But double check your work. I mean, think about it. If you end up with 10 to the 49, you know, I can look at this and see, well, without even dividing this, I should end up with 10 to the 3, 10 to the 4, something in that range, okay? And our answer here ends up being 6.10, and not 0.10, sorry. Boy, I am just messing up left and right, y'all. 610, and we have to put a decimal here so that we can get 3 sig figs. And that should be moles of barium. Okay, now, if I put this into scientific notation, it would be 6.10 times 10 to the second, which is in line with what this would end up being, just with my mental math. Okay, I said that it should be 10 to the third-ish, but we are also dividing here. This number is less than 1, so that's why it ends up being 10 to the 2. Okay, but do you see how you can do some of that mental math and be able to come up with the right, at least double check your work with it? You know, slow down and double check. All right. So here we have 62.9 grams, and that's sodium phosphate. So again, you guys need to be able to write these formulas out. Okay, this is a +1, this is a -3. So I have to have 3 of these for every one of these. I'm going to change my grams into moles. And then I'm going to change my moles into, they want molecules. Okay. So when I do that, now I'm going to grab my values. I have 1 mole here. I need to calculate the molar mass for this. So that's 3 sodiums. They're 23 each. A phosphorus, which I think is 40. What is phosphorus? No. 31 is what phosphorus is, sorry. And then 4 oxygens are 64 each. Add all of that together, and I get 164 here. And then this is 1 mole, and this is the 6.02 times 10 to the 23rd. Okay. Remember, there's a ceiling tile up there that has it on there. If you can't remember it, let me know, and I'll help you. I don't know that I put this on the test because I think you probably have it memorized by now, but if you don't, or you choke on the test and you're like, I don't remember what it is, just come up and ask me, okay? Or look at the ceiling tile that's up there. All right, so I'm going to multiply these 2 values together, then I'm going to divide by this one. And when I do that, I get 2.31 times 10 to the 23rd. You need to make sure that you are putting on your units with these. So that's going to be molecules of Na3PO4. Okay, so molecules of this is my label. This I'm going to go back. Once I get my answer, I'm going to go back and I'm going to check my sig figs. 3 sig figs here, 3 sig figs here. All right, here they want to know which one of these has the greatest number of atoms, 25 grams of antimony or 49 grams of xenon. So I set these up. 25 grams antimony. They apparently did not put down that unit or that calculation on here. 121.3 121.8 grams of antimony in 1 mole of antimony. Okay, and then I've got my 49.0 grams of xenon. Grams of xenon, and I didn't put that down either. 131.3 grams of xenon, and that's 1 mole of xenon. Now, since I'm multiplying these last parts through by times 10 to the 23rd, if I just calculate my moles here, that's going to give me my answer. Does that make sense? So I can save myself a little bit of time by not taking the extra step. Plus, I also save myself the chance of typing in something wrong in my calculator, because it's common that you make errors, just like I did. I typed that in wrong. When I typed this into my calculator, I put times instead of divide, so I screwed that up. But it's okay, because all I have to do is the reciprocal, and then I get the right answer. 31.3, and this one ends up being 0.373. So by doing this, I can see without having to keep, I could go and multiply it times 10 to the 20, or multiply by times 10 to the 23rd and get this in atoms, but I just saved myself a little bit of time. Okay, and we can see here that xenon is the right answer. Okay, and I do need you to show work. Okay, so here I didn't show it all the way out to the atoms, and that's okay. I was able to get enough information to be able to get my answer, but I do need to see some sort of work, mental math. Okay, you don't have to use all of this, like, everything labeled properly in this section. I need to see it labeled properly over here for your final answer. But I at least need to see what you're doing as far as your operation is concerned. And you're like, why? Well, because part of AP is you have to show your work. If you just put an answer down for AP, they will not accept it. So I'm trying to get you trained so that when you take that class, when you take that test, you're ready to go. And I know that's frustrating, but that's just the way it is. And then this needs to be a 3 here. Okay, so I have my aluminum chromate. So you're going to have to be able to write the formula for aluminum chromate to be able to get the correct percent composition for this. Does that make sense? Okay, so aluminum, this is the formula for aluminum chromate. So I've got an aluminum here. I've got 2 of those. So 2 times 27. I got that off the periodic table. My chromium, I have 3 of those because remember we have to distribute through the parentheses. And I did not write down what chromium is. Chromium. Transition metal, I believe. There it is. Can't read it though. My eyes are getting too old. 52. Okay, sorry. And my oxygens, I got that memorized. 12 times 16 equals. Okay, so I've got 12 here because I have to distribute through the parentheses. So 3 times 4 is 12 times the 16 off the periodic table. Okay, so 27. So this is 54 here. 3 times 52 is 156. And my oxygen is 192. So I have to add these together to get my total. My total is 402. And so I'm going to divide each of these parts by the whole, which is 402, and then I'm going to multiply it by 100. So my aluminum ends up being 13.4% aluminum. Okay. My chromium ends up being 38.8% chromium. And my oxygen is going to be 47.2%. 47.8% oxygen. Okay? Now, these values, double check your work. These values should all add up to be 100. Or it could be 100.1 or 99.9, but it's going to be in that ballpark. If you go back and you add these up and they don't, then you goof something. So go back and check your work, okay? All right. This one's asking for the empirical and the molecular. A lot of times people will give me the molecular, but they won't give me the empirical, or vice versa. So make sure you give me both of these, and they should be boxed in. I tried to remind you of that by boxing this in. All right. So rules for this. When we do these, we assume that we have a 100-gram sample. Rule number 1 is to assume we have a 100-gram sample. Rule number 2, turn these percents into grams. Okay. Rule number 3 is we're going to take each of these grams and we're going to turn them into moles. Okay. Hydrogen's already done. It's divided by 1, so that one's an easy one to do for hydrogen. And then oxygen, 31.4 divided by 16. This ends up being 1.9. This ends up being 4.9. Okay. Then I'm going to divide by the smallest mole amount. This, of course, is 1. You should be able to do that in your head. This one is 5, and this one ends up being 2.5. Okay? Then I need to figure out what to multiply these. What's the smallest number I can multiply these by to be able to get this to a whole number? So if I do that by 2, but if I do it to 1, I have to do it to all. So this ends up being 5. This ends up being 10. And this ends up being 2. Okay? So my empirical formula is going to be C5H10O2. That's my empirical. I'm going to box that in because that's one of my 2 answers. Then I'm going to find the molar mass for this. So I have 12 carbons. So I'm sorry, 5 carbons. 5 times 12. 12 is from the periodic table for carbon. Plus 10 hydrogens. Plus 32 for my oxygen. 2 times 16 is 32. I add that together, and my molar mass for this is 102. I'm going to take the 204, which is my molecular mass. I'm going to divide it by my empirical mass, which we just calculated to be 100.2, and I get a 2 for that answer. So now I'm going to multiply each one of these subscripts by 2. So C10, H20, O4. This is my molecular. Questions on that? All right, so the next one is similar to what we did in lab. We're determining the percent oxygen in iron 3 chlorate. So she knew that by heating the sample, the oxygen is removed. So the mass before heating, so here is before heating, and here is our crucible amount. So if I subtract this from this, that's going to give me my mass of the material before I heated it, which if I do that subtraction is 3.38. Now, sig figs, when we're doing these, remember when you subtract, significant figures are determined by how many places there are in the behind the decimal. So here, these are all to the 100th place. So my answer should be to the 100th place. Okay, mass of the sample after heating. So now I need to take my crucible and I need to subtract this from this value. Okay, so when I do that, I get 1.89. the difference between these, since the oxygen is removed when it's heated, the difference between these then is the mass of the oxygen. So that is 1.49. Does that make sense? Okay, chemical formula for iron 3 chlorate. So iron 3 chlorate, this is a +3. Chlorate is ClO3. This is a -1. So I need 3 -1s to balance out the +3 from this. All right, molecular mass of iron 3 chlorate. I need to get an iron, which I think is 55. I can't even read that. My eyes are getting so bad. 55.9 for my iron. I've got 3 chlorines. They come out at 35.5, and then I'm going to have 9 oxygens. 3 times 3 is 9 times 16. So I add all of that up together, I get 306.3. I need to have units on this. Remember, the units off the periodic table are grams per mole, and then you need the formula behind it. So this is the proper units for this. And this we always do our molecular mass to the 10th place. All right. So now we need to figure out the percent oxygen in iron chlorate. Now that's not in our sample, but that's in iron chlorate. So we're going to take the oxygen that is here. So the part that is here. And I did not write that down. So 9 times 16. 144. So we're going to take our part, which is our oxygen, our 144. That's our oxygen. We're going to divide it by the whole here, which is 306.3 times 100. That's going to be 47% oxygen. Okay. All right. So now we're going to figure out if the sample is made up of oxygen from C, what mass is this? So what is the mass of this oxygen? Okay, so sample is made up of this percent oxygen. Well, our sample was 3.38 grams, okay, times point, I'm going to take this out of the percent form, 0.47. I should have ended up with 1.59 grams of oxygen produced. I actually ended up with 1.49. Okay. In theory, that's why they call it a theoretical mass. In theory, I should have ended up with this amount. Does that make sense? All right. Then they want us to do a percent error. I did include on your test the formula for percent error, so you don't have to have it memorized. By the time you get to AP, you should, but you'll use it a lot in lab. So by the time you get to the AP exam, you'll have that guy memorized. All right. So percent error, remember, is, and it doesn't matter which one's first because it's absolute value. Experimental minus theoretical. Again, it doesn't really matter which one's first listed here because it's absolute value, divided by the theoretical times 100. Okay, so my experimental, we said this is my experimental amount is 1.49 minus 1.59 divided by 1.59 times 100. This is absolute value. That's why it doesn't matter which one of these is listed first, because you're going to end up with the same amount. It's just one time it'll be negative and one time it'll be positive, but it's absolute value, so it doesn't matter. Okay. Times 100 is 6.29%. And that is the label. Percent is just the label. You don't have anything after that. All right. Any questions from that? Try to make sure that you're boxing in your answers. That way I know which one's final answer. I don't know that you'll have any work for that one or this one, but there we go. Okay. So balanced equation for this reaction, we had iron 3 chlorate, and it says that it's going to be giving off oxygen. You can use your worksheet if you, or your tables if you need to, but you can probably figure out just from context what this is. ClO3 yields, we're going to give off oxygen. So if oxygen's given off, all that's left behind would be your iron chlorate. Okay. This I have 3, this I have 9. So I have 9 there. There's no way to get this to a 9. So even and odd, I'm going to double the odd, which means I need to put a 2 here. That's going to give me 9 times 2 is 18. So I need 18 over here. I got to put a 9 there. And then I got that. Okay. Questions about the review? Nope. All right. So that is it.
Wait, when you label molar mass, is it always grams per mole?
Yep.
Okay.
Always grams per mole for molar mass.